So here's one of my own sets, which is nice and scruffy. Get the light on that. Somebody's painted it, filled in some holes. Could do with sanding down, and the paint they've used has reacted with other things. The bottom is perfect, but not so with the top. Anyway, I'm going to sell this one on eBay. I'm not touching the case because people enjoy doing cases who aren't into electronics. Now, it's lost its power connector, which we will sort out, and of course there's 3 versions this can be. It's hopefully the square round one, which we do have. I think it is the square round one. It does come with the thumb screws, which I'm bound to lose. Good. So this is the, where's my sheet of paper? This is the Mustang 2000 as a Transcom GBX4000. You don't see many of these. That doesn't make it rare. And of course you get the Roger bleep that's on all the time. And it uses the Cybernet 002F chassis, made in Japan, as in the genuine Amstrad. So I'm going to open it up before we dare power it up. Sort that out later. Now, the chassis is one of those that I love. And when we get to the on the air test, if we get the thing to work, and he hears the Roger bleep, he'll never guess that it's a Transcom. Well, it's a nice genuine set, isn't it? It's one I bought on eBay. And really, the fact I've got to put a mic to it, got to do the power lead, got to provide a power lead and do the service work, I've got to be able to do this in 40 minutes or we're at a loss. So I don't have any qualms now in powering it up. Using the crocodile clips, which I enjoy shorting together from time to time. Right, so we'll connect up the PA speaker to the, I can't see which one's which, to the I can't see which one's which socket, and the instrument test speaker to the instrument test speaker. Somebody's broken the switch off there, so we'll have to recover one off a scrap chassis. That's very clever of them. It's fitted with a headlight, not a good grief. Dazzle. That needs looking into. And we'll get our standard Cybernet test mic on the job. I was halfway through a Gieson KT4004, but it's got a major snag, so it needs a switch. Right, what we got there? RF gain, tone, squelch, volume. Put tone to halfway, and we'll put it on channel 20. And what's monitor? Oh, monitor 9. Testing 1 2. Testing 1 2. Right, that works. Right, we'll tick some, but I can't tick the meter lamp off because it's like a headlight. So with this chassis you always need to do the VCO. A lot of the time this coil's broken because they've screwed it up beyond where it's able to go, with the crystals dropping with age. You often get this coil mashed up because people wrongly think it's the detector when that's the detector. And we usually end up changing the ballast resistor. If the radio won't do 3.6 watts, we will change the ballast resistor. That's a 3 watt part, and how can you, it's a bit difficult getting 4 watts out of a 3 watt part. So we'll make sure we're in picture, and let's go for transmit on channel 20, and it's banging across and doing 3.5 watts. Channel 40, 3.4 watts. Channel, that's me with the volume control. Channel 1, 3.4 watts. Nicely balanced. Low power, go back to channel 20. I will have to change this. I've got to keep an eye on the time. I've got a funeral to play the organ for today. And on low power, it's doing 3.5 watts. I think somebody's linked that out, don't you? Yes, yes, Mr. Tango. 1.24 amps. Deviation, for what it's worth on this test set, wow, 4.5. Let's talk to all the channels at once. I'll do the VCO right now. Channel 1. We'll use a red crocodile clip as an earth lead. There we go, red to black, that's nice. Far end of capacitor, is it 9? Should be round about 2 volts, and it is on transmit. Should be around about 2 volts, and it isn't. So we will just adjust the trimmer. It's not that critical. Drop it to about there. Still the same on receive. Go to channel 40. It's supposed to be somewhere around there. It's supposed to be somewhere around there, so that's fine. The danger if you don't check the VCO, you can end up with a minus number. Is you're going to end up in different temperature conditions, losing channels at the top and the bottom. So it is best to do it, otherwise you end up with a radio that doesn't transmit above 37 or something. I mean, that took all of 30 seconds, didn't it? So, back to channel 20. And let's put that into the signal generator. I'll put what into the signal generator though? So on transmit, we are doing 2779105, so it's pretty well where it should be. I'll tell you what, we'll pull that up now. Let's make a note of that. So far it's transmitting great. The deviation I think is far too high. I'm sure when I put it on the other test set, which is accurate, that it will prove to be what I thought it was. transmitting on 3 channels at once. Frequencies, well, it's neither here nor there. Let's see if we can just pull that up. If we can't, it doesn't matter. But we're going to be able to, because there's plenty of leeway still. There we go. So that shouldn't need touching for another 10 years. Was 2 plus 3 volts, it's now 2 plus 2 volts. That's the D. So let's now look at, when we press transmit, what does the meter say? And it says it's low. Right, sockets work. Let's look at receive. So we'll put the correct frequency in the signal generator, 2779125. And have we got any receive? Yep. Sounds a bit strangled. 0.47. They usually do a bit better than this, but this is excellent as far as CB radios go. Let's just show you the right meter. For 10 dB, 0.43. For 20 dB, 0.92. Squelch is always a letdown on this chassis, especially on the fake versions. So squelch to full on the radio, put the attenuator up on the screen, and you'll see I'm at 1 there. I want it to be opening at 100. Opens at 10. Let's get an accurate. Yeah, it's opening at 9.5 microvolts at tight squelch, which is really inadequate. And the sensitivity end might not get it better than that though. Let's just put that to standby. Set the squelch on the radio. Put the signal generator back on. Straight in at 0.3 microvolts. Right, S meter, let's put 100 microvolts on the signal generator, and the S meter reads a rather tight 6. Oh, which is not how we fill this in. We adjust the meter until it says 9. It can't say 9. Alright, let's see whether we can do anything with the transmitter, whether we're going to end up changing the ballast resistor. So ensuring we're still on channel 20, let's put that on. I don't think anything's going to be out of alignment until we get to this stage, and it may be as good as it's going to do. So I'm looking for the peak. They are spot on. Right, these ones. Never put a soldering iron down polythene cores. was in the correct position. Oh, there we go. 3.7. I just have to check the placement of these coils, because they can end up being mashed about. I need that to cool down now. So I'm just going to pop it up to 14.4 volts. Which some cars charge at, like our Nissan Leaf does. It's 4.1 at that, so it'd be just over the legal limit, but nothing you're going to get prosecuted for. So at 13.8 volts with the hot set, we're at 3.8 watts. Right, let's see whether we've got anything near, because I wanted to be within 0.1 of the band edges. So at channel 40, 3.8 watts. Channel 1 could be a bit more, 3.85. Power consumption, if we go back to channel 20, is 1.33 amps. So I think we need to sort this problem with the high-low power now. And as you can see, that's been linked out. Now, we are bound to have a scrap chassis to recover one of these from, and I know where there is one. Right, so I've changed that, and let's hope we can. Yep, still doing 3.8 watts. Let's go on to low power and see what it does. They're not adjustable on these, you get what you're given. It's 300 milliwatts. So there we are, low power, working for the first time, no doubt, in a long time. I really miss that feature. Not that it's easy to work on these sets, but it's a feature I miss once 2781 had been superseded. I better put the other test set on. I'm really looking at the clock now. So we've done that. It's 300 milliwatts. Replace high-low power switch. Let's get the receiver done. I think we'll call it a day at that point. So, with the signal generator with 100 microvolts on it, just like that. Let's show that on the oscilloscope, and we'll check that the detector is set correctly. Why doesn't that fit properly? Let's use the wrong one. No, it's spot on. So I'm going to go, so we've got about 10 dB on the, no, about 12 dB on the cyanide meter. It just looks a bit not right on the IF. Why doesn't that fit anything today? Try that one. Must have got the wrong one out. Yeah. Well, they seem to be right. Now we'll just go for the front end. Gained a bit there. Just drop the attenuator again. Oh, gained loads there. Right, let's get a new reading. dB is now 0.2. I'm going to be conservative on this. I'm going to say 0.22. I could say 0.21 and a bit. So 10 dB is just slightly less than 0.2, but we'll put 0.2, and 20 dB 0.44. So as far as the receive goes, this is one of those 1 in 1,000 sets that you don't often see. Normally see them around 0.3, but not 0.22 and 0.2. That's fantastic. Someone's going to get a nice set with a tatty lid. Squelch. I'll tell you what, while we're doing the receive, let's get this meter on S9. There we go, that's calibrated at S9. And now let's see if we can get the squelch set. So I really want to be able to squelch S7 out. Let's see whether that's okay. So go over to the attenuator. See whether we can get a bit more on it. We can. So I've got 100 microvolts, but is it any good at the other end? I'll just turn the signal generator off. Squelch. Set the squelch on the radio. Signal generator on. Still point. Wow! Don't often see that. How can one set do it and not all the others? I know component tolerances. Yeah, switches are now fixed. Potentiometers are fine. Right, so let's see whether we're ready for the other meter to read deviation. I'll then see if I can sort that lamp out, because I think it's either the wrong lamp or the wrong resistor, so I have to do something about that, because I can't have it looking like a headlight. It needs to be dimmer than that. It won't last 5 minutes. May as well take picture in picture off. Right, I'm plugging into the test set behind me. Wow, it's actually 3.7 at the moment. So we'll just drop that. Wow. plug it back into the Marconi test set. Back on for this. All white, all the wires in muddled. Wall. It's actually reading right to see. Wallow. It is reading right. Makes a change. So it was 3.7 kilohertz. It's now 2.2 average to a 2.5 kilohertz peak. So that's really good. So I've really just got the meter lamp to do, and that need to do the power lead properly, and that's going to make somebody a really nice set. Right, so I've done the power lead. There's the proper connector. I'm still got it on the crocodile clips. That's the proper connector in square round type. Just changing the resistor. It's 56 ohms. I'm putting 82 in to make it a bit dimmer. I wonder if they've put a lamp in which is less current. I mean, obviously, after 40 years, you're going to end up with lamps being changed. Just change this series resistor. You can see where it goes. So I took 56 ohms out. And we're putting 82 ohms in. I just think it's that bit too bright, and it's going to end up not lasting very long. So of course on the fairy light version of this chassis you've not got this. So positive goes to the on-off switch on the volume control, and negative goes via this resistor to this negative. So where's my cutters? So that's one end. We'll go over this with isopropyl alcohol because it's had parts changed in the past. That's been taped. I mean, it may as well put it straight in at the board. First of all, does it fit? Yes, it does. So put it through, see if we can thread that in. Right, so I'll try and keep that held in position. Can't feed that in properly while holding it, which is not ideal. So we now have a dimmer lamp. I could have got away probably with even going to 100 ohms. So let's see what the lamp's now getting. I've asked Mr. Chippy to put a plug on the end of that power lead, so we're not doing a complete power lead, but kind of repairing what was provided. So once he's done that, it can be on a proper power lead. So let's just see what volts we've got. I think it was 11.82 before with the other resistor. So that's our 13.8 feed. It's 10.08. So we've lost 1.7. Good. All we need to do is remember where we put the lids. We've not done the power meter. We did the S meter, didn't we? I can't even remember. It's supposed to be in the centre of the red zone. We're on low power, aren't we? Whoa, it's above 4 watts when cold. Just the preset there. I'll try and do that and show you. I'll just set it up first. And now I'll show you got it in the centre of the red zone. It's 4.2 watts cold. It was 3.8 when warm. So that's all right. So all that needs to happen is whoever buys this set, if they even can be bothered, it's a plastic coating on these that it could do with a bit of sanding to some degree. That might not matter to some people. In fact, you know what? I think this is paper stuck to it. I'm tempted to run that through my dishwasher and see what the outcome is. This lid's fine. So I say this one is working exceptionally well. I'm not just saying that because I'm flogging it. I don't work like that. I've got a 10-1 set that does 2.8 watts. I'll tell you it's a 10-1 set that does 2.8 watts. Unplug those. I'll come back to doing that because if I go over it with the chemical cleaner, I'm not going to be able to use the set for half an hour and I want to get on with an on-the-air test. So we'll just put that on for now. I'm not going to screw it in. Internal speaker works. Right, we'll switch the test gear off. And plug in the roof aerial. One Nano Roger. About 5:15, so it's tea time, and there you go. Well, that's a lovely set. I'll see what happens on the air test. So thank you for watching the Transcom GBX4000 from 1981. using the Cybernet 002 F chassis and a genuine made in Japan product.